Alright guys, so starting chapter 11, we're not going to do a lot of sections from chapter 11, just a couple, and for the most part they should be review. It's all talking about area. We'll look at maybe some new area formulas with some shapes that we've looked at a little bit more, but the whole general concept is area. This first section, already in geometry, we've talked about area of a triangle, area of a square, area of a rectangle. So the only thing new in this section from what we've already discussed in this class is the area of a parallelogram. So most of this is going to be a review of this year already and then some previous math courses that you've taken. So just a quick refresher, area of a triangle is half of base times height. Area of a square is just the side length squared, which, just a reminder, that's really just base times height, just like rectangle and parallelogram. It's just that with a square, your base and your height are the same. And then, as you can see, the area of a parallelogram is base times height as well. The big thing to remember with height, in all of these cases really, not such a big deal with the rectangle, but remember that height has to be perpendicular to the base. So when you're talking the height of a triangle, you have to make sure you use something that's the length that's perpendicular to the base. Same thing with a parallelogram. You have to use your height has to be perpendicular to the base. So if you've got your parallelogram here, your height will be something like this. Okay? It's not this slanted part, it's this straight up and down part. That's your height. And the reason why the formula is the same as for a rectangle is if you actually cut off this little section and moved it over here, you would actually see that it would form a rectangle. So it makes sense that the area would be the same if you can cut off a piece, slide it around, and have it form a rectangle. Alright, so find the area of parallelogram PQRS. Now there's actually two ways to find the area of this parallelogram. Excuse me. The formula is base times height. But depending on the way you rotate this parallelogram, that can change which one you consider your base and which one you consider your height. But you'll notice you actually end up with the same answers. So here you could look at this side as your base. If you sort of turn, take it and rotate it around so that that's on the bottom. And then that would make this your height because that's the length distance from the base. It's perpendicular to the base, so that would be 4. And then you get 4 times 12. Okay. You could also look at this as your base. Let me erase those other marks that I have, that I just did. Okay. Get back to my pen. You could consider this your base since that's the part of your parallelogram that's actually on the bottom. And then the height, remember that the height has to be perpendicular to the base. So sometimes, and we saw this with triangles already this year, sometimes the actual height is marked completely outside the shape. So this right here is the height, the 8. The 6 is still the base. Just because I have to draw my height down from R way down over here doesn't mean that this length over here is becomes part of my base. It's still not part of the base. So your base in this case is 6, your height is 8. So if we look at that, what do you get when you take, depending on which way you go about it? So again, we said you could take 12 times 4, which if you took 12 times 4, you would get, sorry, I have that as a second. So you could do 12 times 4, and what do you get? You get 48. Or you could take this base times this height, if you look at it that way, and you've got 6 times 8, which also happens to be 48. So you'll see either way you use it, either base you use, because rotating that parallelogram around shouldn't change how big it is. So now we need to find the perimeter of this polygon and then the area. So we'll look at perimeter first. This polygon is a triangle. Perimeter, okay, so we don't have a formula for perimeter necessarily, but think about what perimeter means. It means the distance around the outside. So it's just all the sides added together. Now, there's one little problem with this triangle right here. We don't know the lengths of all the sides. I've got this 5 here, I've got this 13 here, but I don't know this side right here, which in order to find the area, I need to know that side as well. Okay, so I can't find my perimeter and I can't find my area without that side length. Fortunately though, this is a right triangle. And so we know how to find that third side in a right triangle. All right, so we can use Pythagorean theorem. Now you may recognize, hopefully, if not, it's not a big deal, but if you do recognize this 5 and 13 as part of a Pythagorean triple, so that base has to be 12. 5, 12, 13 is one of our Pythagorean triples. If you don't remember that, again, it's okay. One thing we talked about when we talked about the Pythagorean triples is it's okay if you don't recognize them, they just save you some time. If you don't recognize it, then you just have to go through and say, okay, 5 squared plus b squared equals 13 squared. Make sure you use the base, or make sure you make the 13 your c, because that's the hypotenuse. 5 squared is 25. 13 squared is 169, and if you take 169 minus 25, you get 144, and 144 is 12 squared, so the b has to be 12. So you can still find it if you don't recognize the Pythagorean triple, but it just saves you some time. That's the nice thing about recognizing those Pythagorean triples. All right, so now we know all three sides. We know that this side over here is 12. So to find the perimeter, we just add up those three sides. 12 plus 5 plus 13. And 12 plus 5 is 17. 17 plus 13 is 30. So the perimeter is 30 units. Okay, now we have the perimeter. Now we just need to find the area. And it's a triangle, so area is half of base times height. The base is 12, the height is 15. So we get half of 12 times, excuse me, I said 15, it's 5. I apologize for that. Area is half of 12 times 5. So half of 12 is 6, and 6 times 5 is 30. You could have also done that. Remember that multiplication, when you have three things multiplied together, you can multiply them together. You can group them in any order. All you have to do, though, is just take two of them multiplied together and then take that answer times the third part. So I did half of 12, and then I took that answer times 5. You could also take 12 times 5, which is 60, and then take half of that answer, which is still 30. It still gets you the same result. Multiplication is commutative, which means that you can be done in any order, and it's associative, which means that you can group them however you want. So you can rearrange the order, you can group separate ones together. All that is okay. So we end up with, just so happens that the perimeter is 30 units and the area is 30 square units. Doesn't always work out quite that way, but in this case it does. All right. So now we're going to look at doing some backwards working. So the base of a triangle is twice its height, and the area is 36. So this time we're given the area, and we're trying to figure out the base and the height of the triangle based off of the fact that we know that the base is twice as big as the height. So first thing we can do is draw a picture, and there's a lot of different ways we could draw a picture, and really they're all going to be the same. I just chose to draw a right triangle because it's easy to draw the base and the height that way, but you can do it however you want. So if the base is twice as big as the height, I'm going to call the height H, And then the base is twice as big as that, so that was going to be 2h. So when I draw my picture, I get 2h and h. If you drew a triangle like this, there's your height is h, your base is 2h, it still works out. So you can draw the triangle any way you want. It's just easy to visualize on a right triangle. So that's why I did that. But don't worry if you don't draw it as a right triangle, it's not a big deal. All right, so what we need to do now is we need to try and figure out how to work backwards. And so one thing that's helpful on these kind of problems is to actually write out the area formula that you're going to be working with first. We know we're talking about the area formula because we're given the area of the triangle. So it's a triangle and the area is half of base times height. So I'm going to start with that. And then what I can do is I can fill in the pieces that I know. I know the area is 36. I know the base is 2h. And I know the base is h. Okay. So by filling in that information, 36 equals half 2h times h, I can actually I can actually have an equation where there's only one variable. Okay, so now I just need to try and simplify this down, and remembering what I said about grouping, so here I have a half times a 2 times an h times another h. So with multiplication, I can group those in different orders. So right now I have it grouped as the h is by itself, the 2 h's together, and the 1/2 is together. But that's the same thing as if I were to group the 1/2 together with the 2 and the h together with the h. So you can see I'm multiplying, and one thing you learn in algebra and even before that, probably as early as 5th or 6th grade maybe, I don't know how early you guys start talking about that, but it's that with multiplication you can regroup it. So that's all I did here is I regrouped it, because then what I can do is half of 2 is just 1. And then h times h is h squared. Make sure that you remember that it's h squared, not 2h, h squared. H times itself is h squared. So this whole thing can be written as 36 here, and then this side can be written as h squared, 1h squared, because those basically cancel out. And so I have 36 equals h squared. Now you just have to figure out what the height has to be for the height squared to equal 36. And you may just recognize that right off the bat. Well, if you're going to square something and have it end up being 36, it has to be 6. Okay. If you don't recognize that right off the bat, that's okay. You would just need to get rid of the square by square rooting. And what you do to one side, you have to do to the other side. So you square root that, and square rooting a squared cancels it out, and then the square root of 36. Again, you either know, or if you have to type it into your calculator, you can type square root of 36 in your calculator, and you get 6. So the base, so the height is 6 right here, that's 6. The base has to be 2 times 6, which is 12. So the height of the triangle is 6, and the base is 12. All right, last one of the main examples, and then just some extra practice examples. All right, so we're going to paint the side of this barn, and we need to go buy some paint. Okay, the can says that that 1 gallon of paint covers 350 square feet, and we want to know how many gallons we should buy. And so a couple things we can see about this barn is that the side of the barn that we're painting, so we're not painting the whole thing, we're just painting this front part.